All right, so to continue where we were with an arithmetic series, we have another way that we can represent a series and evaluating a series, and that's called sigma notation. So sigma notation, if we take a look at what we mean by sigma, we do have a symbol for sigma. Sigma notation means summation notation. Okay, so again, we're adding things together. Now sigma is a Greek letter, and we have a lowercase and an uppercase sigma. In this case, we're going to use the uppercase sigma. So that's the one that looks like a giant E. That's what we mean by sigma notation. And what's nice about sigma notation is this means that we will always give you a number to start with, and that number is located on the bottom of the sigma, and then at the top is where you stop. So it'll tell you where to start and to stop. And then what they do is they give you a formula. They give you a nth term, an explicit formula. That formula can either be geometric or arithmetic. Arithmetic or geometric sequence. Okay. And I'm going to show you how we can use sigma notation and what it literally means before we take a look at some advancement and some shortcuts based on what we've done this chapter. So for example, let's say that I ask you to evaluate, so show all terms and evaluate. So evaluate means simplify, find the answer. And I'm going to give you, let's go with n equals 1 to 5. And I'm going to give you an arithmetic sequence to begin with for this first example. Let's make it 2n minus 4. So what this literally means is we are going to expand it. Anytime you see a sigma, it means sum. So first we're going to do is we're going to let n equals 1. So the first thing I'm going to do is I'm going to substitute in n equals 1. So my first term would be 2 times 1 minus 4. Then I'm going to add that to the next term, which would be 2. Second term, I plug a 2 in. And I keep going. My third term, I'm going to plug a 3 in, because it told me to start with the number 1. Then I go to 2. Then I go to 3. Well, when do I know when to stop? I know when to stop when I look at the number that's on the top. So stop when you reach the top number of 5. So if I go one more, that's going to give me a 2 times 5 minus 4. And so I've got all the expansion done. It told me to start with the number 2. It told me to start with the number 1. And my last number says to stop with the number 5. So here's my first, second, third, fourth, fifth term. So that's what we mean by showing all the terms. And now we can evaluate or simplify. 2 minus 4. This would be 4 minus 4. 2 times 3 is 6 minus 4. 8 minus 4. 10 minus 4. So if I keep this evaluation, my first term here would be a negative 2, 0, 2, 4, 6. So sure enough, you can see where I gave you an arithmetic series. It's arithmetic because if I add 2, common difference is 2. So if I add these together, let's see, that's 0, 0. It looks like our sum is the number 10. Okay. So that's what we mean by expand and evaluate. Literally, start with whichever number's on the bottom, stop when you've substituted in the last number, which is the 5. But you can see how cumbersome this would be if I said, well, let's start with the number 1 and maybe we add to 500. Well, you probably would not want to have to substitute in 500 numbers. And so I'd like to do the same problem using the formulas that we learned in section 4 of arithmetic series. So I'm going to do this same problem again. Use our S sub n equals n times a plus 1, a plus n last term over 2 to find, and I'm going to do the exact same problem. Sigma n goes from 1 to 5 of 2n minus 4. So this time I'm going to use the formula given in the chapter that we just did, the section we just did. So in order to use this summation equation, I need to know, let's see, I need to know what n is. Well, do we know how many numbers we're adding together? In this case, we're starting with the number 1 and we're ending with the number 5. So that gives us 1, 2, 3, 4, 5 numbers. Now I need to find the first term. Well, how do I find the first term? I find the first term by substituting in the first number they told us to and by substituting in a 1. 2 times 1 minus 4. So our first number is 2 minus 4, negative 2. So we have our first number. Now, according to our equation, we need to find our nth number. Well, since n is 5, how do I find our fifth term? I literally take the last number that we're supposed to substitute in and substitute that in. So our last term would be 2 times the last number we substitute in, minus 4. 10 minus 4 is the number 6. So now I have everything I need in order to calculate by using our equations from this chapter. So now I know the sum of these 5 numbers can be found by, and I'm just writing it down again. So the sum of these 5 numbers is found by taking the number 5. Our first term was the number 2. Our last term was the number 6, and dividing by 2. So that gives me 5 times negative 2 and 6 is 4, divided by 2. So the sum of these 5 numbers is 10. And that's what we got when we expanded. Okay? So we're going to do that one again. We'll just make it a little more dramatic by adding up a few more numbers, just to practice going through that equation from section 11.4 with summation notation, or sigma, and using our equation that we used in section 4 for the sum of this series. Okay, let's try this again. All right, so let's practice, let's do this one. I'd like this sum, and I'm going to give you k equals 1 to 13, and now I have to give you a sequence that uses a K in it this time, and I'm going to keep it arithmetic. So I'm going to give you 4K plus 1. Now, of course, you could expand it out 13 times, but on a test or quiz, I'll probably make that number larger, like 130 of them. So you probably do not want to have to expand this out to 130 terms. So instead, I ask myself, okay, first question, well, it's arithmetic, I'm adding. And so therefore, since it's arithmetic, I know this is arithmetic. I know since I'm adding them all together, because that's what sigma means. Sigma means add. So therefore, I'm adding them all together, so we call that a series. Since it's an arithmetic series, based on what we did on the last lesson, I know I take and follow this equation. And so let's figure out what we do know. We know that we know how many terms there are. I'm going to have you for this year practice always starting from 1. So in this case, I have 13 terms. I know how to find the first term because we know to find the first term, it tells you to start with the number 1, so I substitute in the number 1. So our very first term is 5. Now I also need to know the last term. I need to know my a sub n. Well, the last term is found by substituting in the number to stop, which we always find on the top. So I know that my last term, my 13th term, is going to be 4 times 13 plus 1. So our last term, our 13th term, is 26, 52 plus 1, which is 53. Okay. So now I think I've got everything I need. I know it's arithmetic. I know how to find arithmetic sum. And now I'm just going to substitute in everything I know. So I know the sum of these 13 terms is 13 times our first term, which was 5, our 13th term, which was 53. Divide by 2. So our 13th term is 13 times, what is that, 58 over 2. Reduced by 2 is 13 times 29. So if I add all 13 of these together, I should get, I think that's like 370 something. 13 times 29, 377. And so that's how we use our sigma, which means to add, and our equation from our last section. So just like we did in with the arithmetic series, now that you know what it means, let's figure out how many terms there are. So let's go backwards. Okay. And then we'll finish up by practicing how to write and use sigma notation. So let's do this. Let's determine the number of terms in the arithmetic series that I'm going to give you. Let's say I give you this series. I know it's a series. Series means to add together. I know I'm adding them because I'm giving you summation notation. I'm going to tell you to start with the number 1. This time we don't know how many there are. And since I'm starting with the number 1 and I'm substituting 1 in for k, when I write this explicit formula, there needs to be a k in it. So we know that that means 4 times 1 plus 2. 4 times 2 plus 2. 4 times 3 plus 2. 4 times 4 plus 2. 4 times 5 plus 2. Our very last term would be 4 times n plus 2. And this time I'm telling you that when you add them all together, you get 880. All right, so let's figure out what we know. We know that this problem is arithmetic, and we know that it's a series because of the sigma notation. So we know how to find our sum is n over 2. Well, let's figure out what we know. We know our sum is 880 because I gave you that information. Do we know how many terms there are? No. We do not know where to stop, so we do not know n. Do we know our first term? Well, we can find our first term by substituting a 1 in. So a sub 1 is 4 times 1 plus 2. So our first term is the number 6. Do we know our last term? Well, we don't know what our last term is. We don't know a sub n because we don't know what n is. We can find our last term by substituting n in. So a sub n would be 4 times n plus 2. So a sub n is 4n plus 2. So if I substitute that into my equation, I now know a sub n is 4n plus 2. And now you'll notice we have one equation with one unknown. So we have 880 equals n times 8 plus 4n. So 880 equals 4n squared plus 8n. I'm going to divide by 4, make everything easier to divide by 4. 220 equals n squared plus 2n. This is now quadratic, so you can choose to solve by factoring or completing the square or quadratic formula or synthetic division. But I believe this will factor nicely into 2 factors. I need 2 factors that add up to 220. That'll give us 2. All right, so if we're looking at this, and I'm like, oh, I did it again. This time I forgot to divide by 2. So thank you for those of you that are sitting at home going, hold on, when you did the substitution, you forgot to divide by 2. So I'm just going to back up for a minute. I apologize. If you already have stopped and waited for me to find out my mistake, I started going a little too quickly. So I left off with finding the first term by substituting a 1 in, finding the nth term by substituting an n in, and if I follow the equation, my sum is 880. I don't know the number, but I have my first term, I have my last term, and I need to divide it by 2. Well, if you don't like having a fraction in the problem, we've done this a lot. I'm going to multiply both sides by 2 to eliminate our denominator. So 880 divided or multiplied by 2 gives us 0, 6, carry the 1, 1760, 1,760 is now n times 4n plus 8. Distribute the n. I get a quadratic, 4n squared plus 8n. So of course I'm looking for two answers. I can either solve this by completing the square, quadratic formula, or factoring. But I do notice all of them could be reduced by 4. So if I divide everything by 4, we get n squared plus 2n, and 1,760 divided by 4 is 440. So I can choose to factor, I can choose to complete the square, I can choose quadratic formula, I can choose P over Q's rational root theorem, and use synthetic division. But if I look for factors of 440 that give us 2, I believe we end up, let's see, there it is. How about we need a positive 2, so a 22 and negative 20. Since you all know how to factor, I end up with 2 factors, n plus 22 times n minus 20, which leaves me with 2 possible solutions, negative 22 or positive 20. But since we are talking about the number of terms that we are adding together, and we need to have a natural number, negative 22 is not natural. So we end up with a total of 20 terms that when added together will give us a sum of 880. Okay. And then the last thing I want to take a look at is how for you to write something in sigma notation. So the last thing we're going to look at are 2 examples, because we know sigma notation is using a sequence that can be either arithmetic or geometric. So this will just recap on what we did in section 2 and section 3 of this chapter. So the last thing we're going to do is practice writing something in sigma notation. And again, to reiterate, all right, since sigma notation is just the summation of an implicit, explicit formula, it's either arithmetic or geometric. So just a real quick recollection. An arithmetic sequence, we know, has the equation a sub n equals our first term plus n minus 1 times d. And see if you can write down the geometric one before I do. A geometric sequence, if I want a general term, if it's geometric, a sub n equals, pause for dramatic effect, a sub 1 times the common ratio raised to the n minus 1 power. So that's what we may be using to make our sigma. So let's start with this particular sequence. And then let's rewrite it as a sigma. So sigma would mean series because we're adding them together. All right, so let's do the following. Let's write using sigma notation. So your answer is going to have this sigma letter in it. And I will give you this one to start with. I'm going to give you 601 plus 602 plus 603 604, 605. Well, since I'm running out of room, I better stop at 606. I'd like you to take and write that series. It's a series because we've added them all together in sigma notation. So the first thing we have to do is we have to determine, is this arithmetic or is it a geometric series? So by looking at it, are we adding or are we multiplying between terms? Well, it sure looks like from each one, it sure looks like we are adding 1. Therefore, it's arithmetic. And our common difference is the number 1. So the second thing we want to do is determine the number of terms in the series. Okay. In this case, and we are talking about terms as in which ones we're adding together, you could simply count 1, 2, 3, 4, 5, 6. If we're not sure how many there are, we could have done what we did back in section 2 when we did arithmetic sequences and determined the number of terms. So I'm not going to go back over that. We've already done that. Now what we need to do is the third thing we need, because we've now determined where to start from, we've now determined where to stop, there are 6 of them, we now need to find our arithmetic series, or sequence rather. So find the explicit formula for a sub n. And we know that since it's arithmetic, a sub n equals our first term plus n minus 1 times d. And remember, when we're writing sigma notation, we need to keep the variable in the problem so that we have something to substitute into. So let's start with finding this explicit formula. All right, a sub n equals, well, do we know the first term? The answer is yes. Our first term is 601. We want to keep the n in the problem because we need to come up with a formula to substitute numbers into. And we know our common difference was the number 1. So our explicit formula for any term would be 601 plus, if I distribute the 1, our general formula would be n plus 600. And now we're ready. Now we're ready. If we want to write this in sigma notation, well, where do we start? Let's start with the number n equals 1. That way when I substitute in a 1, I get 1 plus 600, which gives me 601. I want to stop at the 6th term. Remember, we have 6 terms. That's the last number we want to substitute in. And then what do we want to substitute it into? We want to substitute it into the explicit formula n plus 600. And we can check our work by, if I substitute a 1 in first, I get the first term of 601. If I substitute the number to stop and I substitute it in, I get 606. So that's how you write in sigma notation. Okay, and actually looking at the time, it takes us right to about a half an hour. You would do the exact same thing if it had been geometric, only you would have found the explicit formula like we did in section 3 for geometric, and that would go where the sequence term needs to be. So I'll let you guys try that. And until next time, enjoy.